Hello again. This is the third video clip. It's going to be related to the first experiment, electrical engineering and computer engineering experiment. And it's going to be about measuring the resistance of resistors and measuring voltage and a current in a simple resistor circuit, meaning just a battery and a resistor. So you already have seen from the lecture how to read the values of resistors through the colored rings. And in this case, we're going to be, or the experiment calls for measuring and verifying that the 10 resistors that you will pick up randomly will be within the tolerance associated with those resistors. Here, I made sure that I gave you a combination of three 5% resistors and one 1% resistor, just to see how to read them, how to measure them, how compliant they are with respect to their tolerances. Because if they go beyond the tolerance, that means you get the refund for your money. But if it's within the tolerance, then you have to keep them. Now, you know that you should have a data book that where you can record all the results, all the measurements, all the observations that you make. And the reason is that as a professional, you never know what happens. You may be transferred to another department. You may leave to go to another job, and somebody has to go and finish your experiments. But they need the early data because they don't want to go through the steps again. So you have to have a recording book for all your data, and you should have one per group. So in this experiment, even though you don't have a report to write for it, that's the only one, at least at this point, but you still have to record data. And so I'm going to show you a table that I have created for this specific case, where I, as a first column, I have noted the colors of the resistors. Hence, from the colors, I can read the nominal values. That means the values that I expect from the manufacturer. And I have measured them. And then I have evaluated the error between the measured and the nominal value and verify whether it's within the tolerance that is prescribed by the manufacturer. So as you see here, I have the 100 ohm resistor, 1 kilo ohm resistor, the 4.7 kilo ohm resistor, and the 1 mega ohm resistor. So let me show you how the measurements are conducted. You see here I have again the voltmeter, where the red cable is set to volts and ohms. Of course, it all depends on the meters that you get, right? There may be other things that you can measure, but in this case, if I short circuit the two cables, I should read 0 ohm. That's the resistance of a short circuit. So I know more or less that the meter is functioning properly, or at least the battery is functioning. Then, for measuring the 100 ohm resistor, I could measure it in a 2 mega ohm range, the 200 kilo ohm range. But as I said before, if I try to measure it in a 1 mega ohm range, it's going to read something like almost 0, right? Because the range is too high. So obviously I'm going to go as low as I can, in this case 200 ohms. And the reason 200 ohms is greater than 100 ohms, that means I can measure the 100 ohm. And I have as many digits as I can with this meter. And so when I connect this to the resistor, I read 99.6, 99.6. That's what I read before. That's what's noted in the paper. Now, make sure that the resistor is connected or is put in two separate columns. And the column could be here, the other column could be here, could be anywhere, right? But you cannot, because I've seen sometimes in the past where students connect things in the same column. Now, the same column, since they are connected underneath, it means it's a short circuit. And you can check here, you see it's 0 ohm, right? Close to a short circuit, right? Except for maybe the resistance of the connection. So please don't make that mistake. Make sure they are in separate column. Like in this case, I put them this way. And so I measure 99.6. Now in the 1 kilo ohm, for the 1 kilo ohm resistor, I cannot, because I have exceeded the 200 ohm range. So I have to go to 2 kilo ohm, right? I could have gone higher, but I want the most digits. And so in this case, it's reading about 978, 979, which I noted before. Again, 4.7 kilo ohm, that's not enough. So I have to go to the 20 kilo ohm range. And as you see here, it's about 4.61 kilo ohm or so. And then for the 1 megohm, I have no choice but to go to the 2 megohm range. And as you see here, it's about 1.001 or so megohm. So in this case, the unit is megohm, right? With the prefix meg. So one thing about the 1 megohm resistor that I want to point out is that here, let's say, for example, I measure but I also allow my fingers to touch both terminals. As you see here, the value is less than 1 megohm, right? With the other resistors, it doesn't matter if I touch or not, right? It's still, well, obviously, let's go to the 2. Yes. If I go to, even if I touch, it's still going to be 978 ohms, right? But the 1 megohm is problematic. And the reason it's problematic, it's because the resistance of my body is about, as you see here, if I put my fingers on the cable, that's the resistance that I can measure with my body. Now, if I wet my fingers with some water, and now, because the water is more, conducts current better, and so now the resistance of my body is even less, right? And so when I connect to, when I touch, look at this, it went from 1 megohm to about 600 kilo ohm, and now it's even less than that, right? So when it comes to large resistors, your body can affect the measurement. And so that's why when I measure, I try not to touch. I can touch one terminal, but not the second one, right? That way my body does not influence the measurement. And so please pay attention to that when you do measurements, and fill out the table, do the verifications of the errors with respect to the tolerance. And that's the first part of the experiment.